Hey everybody, so we are going to be writing equations in vertex form today. So the way that it's going to happen is that I'm going to be giving you 2 points and we're going to start off in vertex form. You can take that from vertex form and convert any of your vertex form equations into standard form of quadratics as well. All right, vertex form from the vertex and a point. The vertex we're going to be using is 2, 4, and the point is 3, 6. Your first step is going to be to plug the vertex point into h and k of your vertex form. Remember, your h is always going to flip. Here's your k stays the same. So right here, instead of minus h, we're going to say minus 2, even though it is a positive 2, because you're just subtracting a positive 2. It just becomes minus 2. Now what you're going to end up doing is you're going to use the other point and plug it in for x and y. Remember, f of x is another way of saying y. So that 6 is your y value, and that x right there is your 3 value, and you just plug it in. Nothing fancy. So now we're going to simplify and solve for that a value, because we don't know if it's being vertically stretched or compressed or neither. So the way we're going to do that is just basic PEMDAS. Do your parentheses, and you get 1. Then you're going to do your exponent, which also gets you 1. And I moved it as the coefficient of a, so it's easier for us to solve. Do your inverse operations, and you get that a is equal to 2. So it is being vertically stretched since that a value is more than 1. You're going to take that a value and plug it back into that vertex form, and you have your final equation of f of x equals 2 times x minus 2 squared plus 4. So now we're going to take this from vertex form and convert it into standard form. So here's that equation, same one that we just had written down. This is going to go right below everything you have written. Your first step is going to be expand out that exponent, which means you're just going to apply the perfect square. Or you can FOIL it if you don't remember your perfect squares trick. For the perfect square, it's your first term squared, and then the last term squared, and then in the middle is your OI terms, which is your insides being multiplied and then doubled. So it's going to become x squared minus 4x plus 4. If you needed to go ahead and FOIL or box, whatever is your preferred method, go from here, and you would get x squared minus 2x plus 4, which then simplifies to what we already have using our perfect squares trick. Then we are going to have to distribute our a value if there is one. If your a value is a 1, then this part you can skip sometimes. All right, so we're going to apply that 2 and distribute it to all of this perfect square. And you get 2x squared minus 8x plus 8. And don't forget about that 4. Because now we're going to simplify it by combining it in. And now you have that same equation that we had in vertex form right here in standard form. All right, so here's standard. And there was vertex. And that's it.